Hello, my name is Jakub Draganek and I'm Software Engineering Director at Mirubi Software, and we are at Mirubi Studio in Wrocław. I would like to welcome everyone joining us this hot summer evening at the GraphQL Wrocław Volume 6 meetup. If you're wondering why you're not seeing Martin in front of the camera, it's because he couldn't make it due to force majeure. Our first guest tonight is Valentino Gagliardi, and he's going to speak about GraphQL subscriptions. Valentino is a freelance consultant with many years of experience in the IT industry. Hello, Valentino. Nice to meet you. Would you like to start your presentation?
Nice to meet you too. Thanks, everyone, and thanks for having me. My name is Valentino, and I'm a JavaScript developer here in Italy. And tonight I want to talk to you about GraphQL subscriptions in Django.
Okay, nice. Let's jump right into it.
Thank you, everyone, again. Thanks for having me. Tonight, I want to talk to you about GraphQL subscriptions in Django. I am a JavaScript developer in Italy. I love Django. I love unit functional tests. And I love also writing about technology and Django and JavaScript. Most of my work these days is for 20Tab. We are a Django agency in Rome, and we build digital products with Django, React, and Next.js. Let's jump right into the topic. The plan for this talk. We will talk about adding GraphQL subscriptions to our Django project and what it takes to work asynchronously with the Django ORM. To start off, this is how you can configure Ariadne and channels into your Django project. Now, the goal of this talk is to show you how to use Ariadne, which is a GraphQL library for Python with an integration for Django and other Python frameworks, and channels, which is a layer around Django which adds supports for WebSockets to Django. This is a sample from the settings.py from this demo Django project. We have an order app, which is as a simple model loaded. And we loaded Ariadne too, and channels. Both library must be installed into the project. We also need to configure the ASCII application so that it will load it by the ASCII server. Once we configure the project, we need to think about routing. This is how you say to channel how to load your ASCII applications, because for channels, every route that you declare inside your URL router, for example, is a single ASCII application. In this example, we have two ASCII applications. The first application is the GraphQL layer around WebSockets and HTTP, which is in charge for loading the schema that we will see in a moment. Next up, we have also a route path, which is in charge for serving any other view that Django has loaded, for example, the admin or the home page or any other view, really. This project shows how to dip your toes into GraphQL for Django. I am imagining that you maybe have already a Django project in place and you want to integrate step-by-step GraphQL into your project. To do so, you can live side-by-side your views and add, in addition, another GraphQL view, which will serve your schema, your subscriptions, and your queries. This is an example of the ascii.py file. And here we load the schema, which we'll see again in a moment from the order application. And we declare an URL router, which will serve both the GraphQL endpoint and any other view that the application has already in place. So URL router is how you say to Django channels, load these ASCII applications and make the user happy. Once you configure the routing, you need to wire up a minimal schema. Now, this schema is simple on purpose. It is just for showing you all the building pieces. We have an enum, which declares the state for a sample model, which is order. And we also used a scalar date type from Ariadne, which is later loaded in the executable schema. And here we have a user type, an order type, which is connected to, the user is connected to each order. And we also declare a query. We won't use the query in this sample application, but the query must be declared because Ariadne wants it to load the old schema. And we have the subscription here, which will give us, in this example, just the last order that a user placed in the system. So this is how you declare a subscription in the schema here in GraphQL. Now, I want to stress that I'm not a backend developer, but I can work my way out with Django, and I enjoy building stuff with it. And this talk is a tale of my adventure while integrating GraphQL Ariadne subscriptions into Django. With the schema in place, we go where the real meat is. Now, this is the schema.py file from my orders application. I took out the schema for brevity because it wouldn't fit in this slide. In brief, we load a subscription type for Ariadne. And to fulfill a subscription in Ariadne, we need two functions. The first function is a generator function, which is in charge for loading the actual data from the database. Now, if you're familiar with the generator function concept in JavaScript, a generator function is a function that can be resumed and stopped at will. And an asynchronous generator function, which is the function that we need here, instead is a generator function which returns to the outside a generator object, which you can basically consume from the outside with an asynchronous iterator. The concept maps almost one-to-one with the JavaScript concept of a generator function and asynchronous generator functions. Now, keep in mind that this example is just for demo purpose, so it is nothing that I will suggest using production, but it is enough to show the concept. In this generator function, we load the data from the database. And what stands out here is that while in an asynchronous generator function, we cannot directly access the Django ORM like that. Because at the time of this talk, the Django ORM is still synchronous, so you cannot use it in an asynchronous context unless doing a small trick that we'll see in a moment. So we have this asynchronous generator function, which gets data from database, and we need also a resolver, which can talk to Ariadne and give back the data to the client. So we need these two functions. Once we we define these two functions, we pass the schema, the scalar that we used in the schema, and the subscription to the make executable schema function. I omitted the query here for brevity. Now, what happens if we try to use this code in our Django project? We get this scary error. You cannot call this from an async context. Use a thread or sync to async. As I said before, the Django ORM is synchronous to this day. but there is work in progress for adding the asynchronous layer to the ORM. In the meantime, we need to use an adapter in order to talk from an asynchronous context to the Django ORM. How do you do this? If you want to try out this subscription in the playground, you will see that even with the GraphQL debug turned to false, you will see this error in the playground. How do you make the Django ORM work inside an asynchronous context? While working with channels, we can use this function, database sync to async, which is a small wrapper around sync to async from ASCII ref. So if you, for example, if you deploy a Django project under an ASCII server and you're not using channel, you can use sync to async from ASCII ref. If you use channels, you can use this adapter, which also closes any connection when the connection gets when the connection is closed by the client. And this is the first step in making the Django ORM work within an asynchronous generator. We have this function, database sync to async, which wraps the ORM access. Here, for this demo, I am returning the last order created in the database at any given time from a user which is buying something in our shop, in our fictional shop. And you call this function by passing in another function. I used a lambda function here for brevity, and you call this database sync to async. The result of this call is the actual data that is fetched from database. And this is the data that you pass to the resolver, that Ariadne passes to the resolver. This is the subscription that you can fulfill with the machinery that we saw before. So you need an asynchronous generator function and a resolver. Now, things look simple if we fetch just the outer layer of the field of this model. What happens if we want to fetch also the user which is connected to this order? And we have a foreign key relationship here. Again, we will get this. You cannot call this from a sync context, blah, 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 because we are trying to access the foreign key, but Django won't evaluate this foreign key immediately. So that will be evaluated in a synchronous context, not in an asynchronous context. And to make this work, we can use select related, which forces the evaluation of the foreign key relationship inside the asynchronous context. And here again, we have database sync to async, we have a lambda function, and we get the last order from the database by issuing also just a slightly bigger query to fetch also the related user. And this will make the subscription work. So here's the subscription that we requested to the server, and here's the response with fake data, of course. And we get the state of the order, the date of the order, and the date is handled nicely by Ariadne with the dates color, which is a nice utility for working with date field in Django. And we also have the user with a username and the email. Usually, depending on the decoupling style that you put your Django project in, we might have a JavaScript frontend that is loaded by a Django template. This is a common pattern for decoupling Django application. But most of the time, you will have a Django application living on a different origin from the front end. And for make it work cross-origin resource sharing with the GraphQL endpoint, since channels builds on top on Starlet, and Starlet is already included when you install channels, you can use this asynchronous course middleware. So you can wrap your GraphQL layer inside this course middleware, and you declare what origins you need to allow. Of course, the star is idly described in production. This is for development only. But you need to pay attention to allow all the methods in order to send also the options. The first option, the option request, the pre-flight request that the front end needs to send first of all. And the other path remains untouched, loads any Django view that you already have in the project. How to use GraphQL subscriptions in the front end. There are many competing GraphQL libraries, but I enjoy using Apple GraphQL. And in that case, you have to pay attention to use both the HTTP link and the WebSocket link. Otherwise, any GraphQL query will travel over WebSockets, which is not what you want. You need to instantiate both the HTTP link and the WebSocket link, configure the client to use a split link function, which forwards the right link depending on the protocol of the request. And that way you will use GraphQL queries over HTTP. And as soon as the subscriptions gets activated, you will use the WebSocket link. Historically, to have persistent WebSockets, we needed to employ weird tricks in the front end. With Apple GraphQL, you can just declare these options, reconnect to, and the client will try to reconnect to the backend if the backend goes offline. Lastly, you can use the use subscription hook if you're writing a modern React application based on hooks. It's everything for this talk. Thank you very much. If you have any question, I will be happy to reply. And I also wrote a little tutorial about these channels and Ariadne adventure. And I just published a book about Django and JavaScript frontends. And this has been reviewed by your Marcin. Thank you very much for being my technical reviewer. Thank you.
Okay, great. That was really great. GraphQL subscriptions are little known and sometimes frightening topic in a GraphQL community. So thank you for this thorough presentation. I just have a question. Do you feel that subscriptions are really production ready in GraphQL world, and do you see any shortcomings that we should be wary of when choosing to use them instead of alternative solutions?
I think WebSockets are not a straightforward topic. So while on HTTP and REST APIs, everything is battle tested these days. WebSockets are a bit tricky sometimes, and GraphQL complicates a bit the scenario. But I feel that with Apollo client and the work that the community is doing with Ariadne makes this pattern really production ready.
Okay, thank you very much. That's nice to hear. I like subscriptions. I would like to see them more. Okay, thank you, Valentino. That was really great presentation.
Thank you.
Let's move forward to our next guest tonight. I would like to introduce to you Rafał, who is also a developer at Mirumi Software. Rafał is well experienced in GraphQL, and his presentation will share his personal experience and lessons learned the hard way. Okay, so hi, Rafał.
Hello, everyone. Thank you for introduction.
Would you like to take over from here?
Yeah, please do.
Okay.
Okay. Okay, so hello, everyone. As Jacob said, I'm Rafał, and I would today like to tell you a few things I wish I knew when I was starting my GraphQL adventure. So first thing first, a little bit about myself. So I'm a full-stack developer working at Mirumi. I'm also co-creator and lead developer for Ariadne, which is a Python library for implementing GraphQL servers. I'm using Ariadne to build GraphQL APIs for our clients at Mirumi, and I'm also using it for my own personal hobby project. So this talk, I found GraphQL somewhat tricky thing to learn. So when you search for the problem, multiple solutions will come up, but you likely have no extra content to select which one will fit for your use case. Likewise, if you like to research some of more advanced GraphQL features like subscriptions, you'll probably find the text telling you what they are, but not really why you would like to use them, why not, or how even to use them. So in this talk, I would like to give you to both show you some basic GraphQL patterns that are proven but tested, and also provide you with some basic introduction to selected few most GraphQL features that I found interesting. So this pattern I would like to present is putting your passive validation in resolvers. So we were starting out with GraphQL. We noticed that it already has the validation system built in. And we decided that perhaps this is the way we should go. So we started experimenting with custom scalars, then we moved on to the custom directives. The problem is this result with schema implementing business logic, and it's not a good way in the long run. So the recommended approach, IMO, is that you should put your validation into resolvers. So we have the example resolver that services the register user notation in some GraphQL API. It takes the input from user, it validates it. If it's valid, if it's invalid, it returns the errors. If it's valid, it creates a user account, it authenticates user, and returns result with user and token. So why do I feel that the resolvers are the best place here? So first thing first, resolvers know everything, know all of the user input. This means that you can validate the parts of input against each other. So if you have the username in the email, you can hit the stop for spam service API to see if those combination is known as the spammer. Likewise, the resolvers also know about the query context, so know about the user's authentication authorization states. Resolvers are also the safest place during the query execution to run the API calls or do the database queries. Lastly, they also have the total control on what data they return. So you can return only errors when the validation failed. You can do the partial success where the both errors and partially updated object is returned. Or you can return success, only return the final object. Also, if you ignore the fact that this is a resolver, it looks very close to how the box standard controller in any other API framework in Python looks like. There's input validation, there's error handling, and success handling. So you're probably already familiar with this pattern. So GraphQL also allows you to define custom scalars. So you can define the scalar that checks if given value is a validate string or monetary value. I found that those are great for implementing the contract between the client developers and the backend developers, but not so good for doing the input validation for the end user. This is because when error in scalar happens, it interrupts the validation of the remaining states, remaining inputs. So please treat the custom scalars as a way to enforce contract between the client and the backend developers. And if this error happens to the end user, treat this as a signal that you should tighten up the input validation in the client application. Lastly, if you would like to expose the validation constraints to the client, please consider implementing custom type with exposing those constraints in your schema. Okay, so this one is my favorite. So here's how GraphQL default error messaging looks like. So initial idea we got is that we are supposed to somewhat customize or extend this system. In fact, the GraphQL, the Apollo server already does this, implementing few custom errors on the top of this mechanism. And this is explained in this somewhat popular blog by Apollo. So this blog also has the JSON snippet that looks like this. So this is the JSON payload that Apollo server returns to client when the bad user input error is raised from the resolver. I've seen this JSON snippet brought up probably dozens of times by now. And it's always used as an argument that you should use the built-in error reporting mechanic for errors in applications. But the problem is there's 2 paragraphs of text right under this snippet that I feel everybody's missing, but they are quite good. So turns out the idea to keep errors as the part of the schema was always there, but we just don't read. Instead, we skim for the code examples. Also, the second paragraph has quite good link. So Apollo has this document called Schema Design Guidelines. I recommend you giving it a look when you have time. In this document, they are recommending the approach to report to mutation results like this. So it's a good start for error reporting, but I have settled at the better pattern that, for example, supports returning multiple errors for a single mutation. For example, when your mutation is servicing the for validation. So here are the 2 types that you need to implement this pattern. So there's a generic mutation error type that is shared by all mutations, and there is some mutation result. This result type is usually reused across the family of mutations. So it has 2 fields, errors and the instance of resulting object. So if mutation fails, we only get the list of the errors. If there's partial success, we get the errors and the object instance. Or if it's success, we only get object instance. So this pattern is also great for if you're using the client library that use the automatic UI updates for you, like Apollo client. But we didn't end there. There are people researching other patterns for different extra scenarios, not just mutations. I will not present them here, but I would like to recommend you to check out this talk by Sasha Solomon from Twitter presenting those approaches. So next one, don't attribute mystical powers to directives. So I see that plenty of people studying what with GraphQL run into directives, and they assume that directive is like this secret GraphQL solves to all their problems. So here's how example directive looks like. So this is the query cost directive from Ariadne. The idea behind it is that you annotate the parts of your schema with the cost directive, and if the query requests too many of costful fields, the server prevents the query from executing and returns the error instead. So it's simple enough. The directive is like 2 words and the digit. But here's how this looks like on the server side. So here's the entire Python logic for this directive. If you try zooming in to look at the code, don't bother because the Carbon crashed while rendering this code for me. It's only a part of it. So the gotcha with directive is that GraphQL spec tells you how to declare directive in the schema, but it doesn't tell you anything about how the server should go about implementing the business logic for this directive. So we as server authors are resorting to implementing batch of hooks in the libraries to let the developers to either scan the GraphQL schema when server starts to do something with the schema object, or do something with the query object against the schema object at the time of query execution. So this means that directives are a pretty low-level feature of GraphQL servers. They operate on the data structures not coming from library, but instead very rudimentary data structures coming from the GraphQL implementation. So this means you need to know those data structures and how they are working with each other. Also, in case of schema directives that are extending or adding behaviors to fields or types, they're somewhat hacky in their implementation, because the way they work is they scan the schema for the occurrences of those directives, and they let you, as the end developer, take the object from the schema, wrap it around with your custom behavior, and then put this wrapping behavior back into schema. So you're effectively mutating the schema object in place. So next subject I would like to bring up is relay or not. So first things first, relay is a GraphQL client implemented by Facebook for React.js. It's also a specification how GraphQL schemas should implement the object retrieval and also collections of objects and relations between objects. So relay tends to come up during discussions like which client library would you like to use? What are the best practices to design schema? How to represent relationships or collections in the schema? Or even how do we do pagination? So relay is not a silver bullet. So for example, it tells you how to design the schema, but only some parts of it. It doesn't care about the rest. So you're still capable of making mistakes in the design. Also, because it's a specification, your GraphQL server needs to speak it. This means extra libraries on the server and extra developer work. Finally, you might also not like relay's opinions. So don't obsess about having relay because it's technology from Facebook, who are also creators of GraphQL. Give it a look, research it, and make a call if you like it or not. Remember, there are alternatives exist, like Apollo Client, which I also find very good. So next pattern is proxying your data reads from resolvers. So here we have example GraphQL query for Internet Forum application. This query pulls list of the threads. And for each of the forum threads, it also pulls the last user to post in this thread. If your resolver is naive, it probably get the thread object. It will pull the last poster ID from this object, and then you will run database select using this ID. What will happen next is, because this result has 100 threads, you run 100 selects against the database, killing the performance. This GraphQL's famous n+1 problem in action. And the solution for this problem is now, depending on the stack you're using, either as data loader or data source. So those are, in a nutshell, a proxy layer between resolvers and data storage that know how to retrieve data of given type. So you probably have data loader that knows how to pull users. You'll have data loader that knows how to pull products from the internet store. So resolvers have data loaders for data, and data loaders know if the data was loaded already, or also how to batch the loads. So in looking at the previous example, the user data loader will know that 100 resolvers ask for, let's say, 50 different users, and this user data loader will load those 50 users in single database query, and then will delegate the separate result to each of the resolver calling it. So the big problem with data loaders is that the behavior I've just described is actually quite complex on the implementation side, so I will not dwell into it. But we as Mirumi did the talk on this matter on the previous meetup, and I will offer the link to it after the talk. And now I would like to tell you how we are testing our GraphQL APIs at Mirumi. So at Mirumi, backend developers are writing Python tests that run queries using the test client against our GraphQL schema. So those tests check the entire query execution stack. So they check if the resolver is processing the inputs correctly, if resolvers perform their logic correctly, and also if the result of resolution meets the contract with the schema. We use snapshot tests to avoid writing dozens of assertions for larger results. And for mutations, we also add extra assertions to verify that application's business state has been updated correctly. And for edge cases, we don't repeat the entire complex test, but instead we write the much simple unit tests that call the resolver functions in isolation using mocked mocked arguments and only verify the return type or the business state notations, like running, for example, database query to pull out the user that should be registered or not. But we are also using end-to-end tests. So those are tests that our quality assurance team is maintaining for us. Those tests test the contract between the server and the client. But because they have longer setup time and they are heavier to run on your dev machines, we result mostly to running them on CI. And during the regular development work and iteration, we are resorting to the previous approach I've demonstrated. So next one. So this is a bit of advice from me. You might want to consider disabling the introspection. So GraphQL has this feature now called introspection. What basically is, it's that the query type always implements the special fields with the name starting with double underscore. For example, there is a type field or schema field, and those fields can be queried to retrieve the information about the schema itself from the server. On the slide, you can see the introspection in action with me picking at what are the contents of the GitHub's GraphQL API. So I'm using the schema type to retrieve the contents of the schema, and also using the type field to retrieve details on a selected type. So the problem with this seems to be obvious. If your business logic has some mechanisms you don't want to disclose to your end users, perhaps you have user trust scores, or you are doing shadow banning of the users, or you have staff mutations that you don't want world to know about. The person familiar with GraphQL may use the GraphQL client to query, to run the introspection against your schema and find out about those. So I'm recommending disabling the introspection in your schema. Okay, so lastly, I would like to also give the word about subscriptions. So on FuseLog, subscriptions are very attractive to developers. They promise you the easy way to do real-time updates in your API, in your client, but there are gotchas here. Subscriptions use WebSockets, and those have very limited browser API compared to the regular HTTP requests. For example, WebSockets don't support custom HTTP headers, so you will need to have the alternative way to do authentication in your client. You have to either embed the authentication token in the WebSocket message, or you will have to consider the old ways of having the session ID in the cookie. Also, WebSockets are excluded from cores. So I have seen people stumbling on this because they were thinking that they are querying the WebSocket endpoint, when in fact they were receiving the 4.3 error from the server because the method they were using was not implemented. Okay. Also, the little dirty secret of subscription is that they are not really used that frequently. So this means that they are not getting too much attention from server developers. So expect inaccuracies or missing or blanks in the documentations, also long-standing bugs, and other limitations in the server implementation. So my recommendation for subscription is that don't bet big on subscriptions before trying them out on your own software stack. And consider that short polling might be much easier alternative and give you the same results returning on your use case. So that was it. Thank you, everyone. I hope this was useful to you. Any questions?
Yeah, I bet. That was really great, Rafał. That's a lot of knowledge to process. And I really wish I knew this when I was writing my first service. As a matter of fact, it was so much knowledge that we do indeed have some questions from the audience. So can we pull back? Okay, we already have one question. So Rafał, does that mean that all errors will be served back in the data object of the GraphQL response?
So great way about, I'm not sure if this is about the validation or the second one, but the response that comes to my mind is that It's absolutely up to developers which errors you want to put in the data object and which ones you want to put in the error payload. We're actually using the mixed approach on one of the projects where data payload is something that we are intending to display to the user in the UI, but we are still using the errors key to communicate, for example, expired authentication tokens, and this is handled by the client part of the GraphQL implementation.
Okay, thanks, Rafał, for an answer. We can go to the next one. So, how do you make sure that all error cases are are covered and you don't lose an error because you forgot one?
To be honest, you don't. As application developer, you can probably predict which error codes or error types you will expect in this place to happen, and you can prepare for those.
Okay, that was short and brief.
Yeah.
Okay, so I think we've got another one in the lineup. Yes, for someone who wants to integrate GraphQL into Django, what do you suggest for data validation? Is it a good idea to use DRF serializers? Serious question. Nice
question. I never got to the DRF serializers. I think they will work fine. I've used Django forms actually, but my inputs were much simpler. But you have, I don't know, arrays in your payloads, and probably serializers will be the way to go. I have also used the pydantic models to validate. Actually, the error type I presented on my presentation was one-to-one GraphQL representation of pydantic validation error.
Okay, great. Okay, so thank you for all the answers, Rafał,
and
your very thorough presentation. That was really amazing. Right now, we should proceed to our final guest tonight, which is Stehpan Schneider, who is joining us from Berlin. Stehpan works as a backend developer at Contentful, and his presentation is about error handling in GraphQL, which we all know is not a piece of cake. So, hello, Stehpan. How are you?
Hello, I'm doing well. Thanks for having me. I'm joining from outside, from Berlin, Germany here. Happy to be here. Actually, would have even more liked to be there in person, but we'll get there soon, hopefully.
One day, Stehpan. Okay, so let's jump right into it.
All right. Cool. So yeah, I really love what we have heard so far because it's touching a couple of points that I'm going to talk about today. So it's easy when you're just like listening to some like tutorial or even like here on a talk, how easy it is to get like GraphQL, getting it up, getting it running, getting your first responses out of it. And that's exactly how I've started with it as well. But quickly you will realize that there's like no perfect world and you will have like some errors. And that's why we are here today, because dealing with errors is not always the nicest thing to do. And I want to try to convince you that it makes sense to like treat them consistently, treat them like from the very ground up, and don't think of them like as a second-class citizen just after you have implemented everything. So as mentioned already beforehand in here, that's why I really like the partial success will be also making it just more difficult to deal with them consistently, especially if you're going towards like monitoring or things like that. You cannot rely on the same systems as beforehand with your REST APIs and, you know, the alert on a higher level of 400 responses, because there might even be failures within your 200 responses. So why I'm actually the person sitting here and talking to you about that. I'm an API developer for about 5 years, I would say. I mean, I have been working on APIs and with APIs beforehand, of course. But since I've joined Contentful, I am considering myself more as an API developer because the company is like API first. In 2018, I started picking up GraphQL just like on the side, just for me experimenting around. This was like a very intriguing technique and it's up to today. And at some point, we started a project at Contentful using GraphQL. We didn't have like much experience with GraphQL prior to the project, except for my place that we had beforehand and like some other colleague who had built like a rough proof of concept, just basically using the REST API. By now, we are on a native GraphQL that's not using REST in the background at around 4 billion monthly calls, a code base that I have heavily contributed to and I'm maintaining up until today. And the cool thing about that is that we're actually generating a couple thousand schemas every month, because every user can have their own data model, and based on that, you get your own GraphQL API. I've actually covered that in one of my other talks beforehand. And this is a very specific thing, which is not up for today. So what we will be looking at first is the GraphQL request lifecycle to get when we are sending a query and we've just sent this string of text and we get some data back. What is happening in the meantime, and what are the points where it could go wrong? The first one that we have is the transport layer. So as was mentioned beforehand, we have GraphQL as transport independent. You could use via WebSockets with the subscriptions. You could theoretically use gRPC or something like that and serialize your data, but most often is actually used via HTTP, and that's also what we'll be focusing for the examples here, because that's the only thing I've been really excessively working with. Error examples here are things that happen before you even reach the GraphQL part of your server. You might have some constraints on your request payload size, the query string might get too long. You might have a custom post body size. We have, for example, so that we can guarantee that your request will be cached on the CDN. Those things need to be considered beforehand and might be their own error cases, but you still want them to be formatted in the same way as all your other errors are. For example, as well, if you're running into authentication problems and you're actually having no authentication at all, you're sending an invalid token, maybe even things like you're running into rate limiting and some other service beforehand is returning the error. But yeah, that won't be covered here because we're actually looking on a error pipeline on the server and not on the CDN beforehand. Once you get to the actual GraphQL server, the first thing you have to have is a schema. Here it's the tricky part at Contentful. We have a bunch of schema level errors, when we're generating a schema, because we're generating it from customer provided data, and that can go wrong, of course. Most of you probably won't run into this, or if you do run into it, it will be covered by your tests, because you're probably dealing with just a single static schema. And when that thing fails to generate, all your tests will fail, of course. An interesting thing here was that actually GraphQL requires you to have a type name starting with an underscore or A to Z. So you cannot start it with a number. We had types that could start with a number, and we had to make sure that we prefix them so that the generation still works. You could have naming clashes that can happen even when you're using a single static schema, that you just made some mistake somewhere and you have two types that are now having the same name or resulting in the same name. These are prior to the execution, but it is after you have actually received the message. So let's go one step further. Document parsing errors. What is a document? A document is what GraphQL uses to evaluate your query. You send it a string. The string gets parsed into a document. And that means that you're tokenizing everything, and you try to make sense of it from a syntactic way. GraphQL has a specification of the language, and if you don't match its syntax, there will be failures. That is independently evaluated and not using your schema, because it's just it's not making sense out of it, it's just the syntax. And if that fails, then most likely your customer or your user needs to be needs to change the request to make it work. Example or simple examples here are just you mistyped query. It's just a typo. Here, the E is missing. Or you're sending parentheses for arguments, but you're actually not putting arguments in there. GraphQL as a language says this is not okay. And this is handled by the GraphQL engine in whatever language you are using. In the later state of the talk, I'll be showing you some error implementation or error pipeline implementation, which will make use of the GraphQL JS reference implementation, utilizing some TypeScript, but no worries. If you don't know TypeScript, that will be fine. I will walk you through. Once we have parsed the thing into a document and we know that it's syntactically correct, GraphQL tries to make sense of the document and what you're trying to achieve. It does that by applying some default set of validations you could remove, but I don't recommend you to do so. And for example, it is enforcing that a fragment you have sent in your query is actually used. In the error example down here, you will see that is not the case. You're not using the foo fragment. So GraphQL might decide to just send you back an error being like, hey, that fragment is unused. Could also be, I think, if you are trying to use fragments on types that are not supported. That is validated against a specific schema, so you don't know what type it is, what type a fragment can be used on if you don't know the types of the schema. So it has to be validated with the schema. You can put your own validations in there if you want to, and I think one pretty common thing to do so is for the schema complexity. So if you, I think we have seen that as well when Rafał was showing the, I think it was Rafał showing the directive implementation. Those things can throw errors, and you want them to be handled in the same way as all the other errors. Streamline them so that you see it. And then the meaty, juicy part, the execution phase errors. So actually everything that is concerned with your business logic, some database request failed, something wasn't found. Maybe even the custom scalars that we have seen in one of the 2 talks beforehand as well. If we send I think that's the US style of sending a date, which cannot be represented as an ISO date, you only know that once you have executed the code, the business logic, that is defining what a date looks like. This is the most frequent thing you will run into, and you will want to make sure that all of them make sense to the user. So why do we actually want to do that? Because we want to walk the user somewhere. We want them to know what is going on. So before we can think about why we actually need to do something custom, we should maybe know how a GraphQL error actually looks like, which we will see here on the slide. So there's some data and maybe some errors, and the errors look like this. This is the minimum viable GraphQL error, basically. You have some message and you have some, I think even locations and path are optional, but they're most often added by the GraphQL error, the one that is coming with the reference implementation, and we'll be talking about that in a minute. This error in itself is not really useful, is it? So what actually makes an error useful? The user has an idea what went wrong and where. This is why there is the location and the path. So you know where you have to look in your query or to see what might be going on. You want your user to be able to make an informed decision on what to do next. What to do next can be as simple as retrying, or it might even point your user towards that they need to change their query to be able to repeat it and then be successful. Bonus points if a machine can reliably work with your error shape. For us, that's pretty important because we're an API-first company and we want customers to be able to integrate with our API and handle the errors by a system they have developed. So what you can do to make your errors more user-friendly is, first of all, to use only specification-compliant fields. That is a bit contrary to the other approach we have seen beforehand, where we actually maybe mix the errors into the data object and so on. To be honest, it's the first time I've heard of it. It's kind of interesting concept, but I will stick here to having the errors in the errors and the actual successful result in the data properties. Within an error, you only want to use specification-compliant fields as well, so that you make sure that everyone can handle the error that comes back, because it is not as strictly typed as we have heard. You should make sure to use the available fields from the specification if you have them at hand. So if there is something going on that is not, that cannot be pointed back towards the location or path, it's of course okay to leave it out. But if you do know in which specific section of a GraphQL query something went wrong, it should be in there. And then there is this nice extensions field, which is a free-form record where you can just put basically everything in or anything in there that you want. My recommendation here is that you use a namespace with a key that won't clash with other APIs, because they can be stitched together. And if you, for example, combine the GraphQL API from GitHub with Contentfuls, you want to make sure that if one of the two is failing, it doesn't override the others. So we decided to put everything into the contentful namespace. Another thing that we found pretty much lacking from the specification is like a static error code. The message, in our point of view, is more towards the human readable form. And you might want to change the wording if it's necessary. You might want to put more information in there, whatever. So we said we want to have a static error code that never changes because we're pretty serious about backwards compatibility. So once you have that static error code, you can always look on that specific field that has an error code and react on it as you wish for. And last but definitely not least, add a request ID. Like seriously, add some sort of request ID that makes it possible for your engineers or support engineers to be able to find a request again. So at some point, a customer reach out having problems with specific requests, and you want to be able to guide them or like ask them to send you the request ID and have like some more information in your backend system. So with that knowledge, this is how useful yet GraphQL specification compliant error looks like. And as you can see here, we have put in there the extensions with contentful, and now we have like a code, internal server error, and we have a request ID that you could send to support and ask what is going on. This is even better because now that we have like this namespace, we can put in there whatever we want. We can help the customer. We can guide them towards what they should be trying or doing. Here we say, like, sorry, this locale doesn't exist that you wanted to get data inside of. So instead of just saying like, yeah, it didn't work, we actually can put details on there and point them towards, hey, there are available locale codes, and those are those two. German is not one of them. Please choose one of the two, and it will be successful. The customer can change the query and will be successful. So where does actually this information come from? Like the location, the path, everything you have. There is the GraphQL error type. This is the one I was mentioning shortly earlier, which is shipped with the reference implementation of GraphQL, like the GraphQL JS. What it does is, it is encapsulating other errors. And I know this is like a bit overwhelming maybe, so let's walk it through it step by step. The GraphQL error has a message as well, which can be like this human readable error message. In the approach I will show you today, it is actually not as useful to have the message field because we are trying to combine errors from that might be happening before GraphQL kicks in to the point where GraphQL is used. And we will be implementing our own error type that will be used afterwards. Notes and source is like this parsed string to the document that I was talking about. And in my point of view, is mainly used to be able to pretty print errors while you are developing, and it shows you like where in the query something was going on in a visual way. The same with like the position in the past. That is derived from at which point in your GraphQL document you are. If you create that error by yourself, you would need to put it in there by yourself. But everything, for example, that throws within a resolver will automatically have this data attached because the GraphQL engine knows at which point in time which resolver you were working on that failed, and the customer will be able to look at exactly this portion of the code of the query to make sense out of the error that was coming back. And the most interesting thing is the original error. You can wrap, like the GraphQL error wraps another error type that you have, and within that error, that is completely up to you what you are doing. And we'll be utilizing this approach so that we can streamline it from start to end. And then lastly, there's also extensions. You can use it, and you can use it together with the message thing and basically rely on the GraphQL error to handle everything for you, which might sound intriguing and easy in the beginning, but as it is not as strictly typed for us using TypeScript, it wasn't so good to actually use it. We couldn't enforce that specific information is present on an error. So we decided to actually just use the original error and then apply some formatting for us at the end of a request after everything has happened and executed. So yeah, bring your own error. For us, it was the approach was that we have this original error, and inside this original error field, we usually have like a Graph API error. A Graph API error can be created from outside, like when we, like before the execution started, but we can also throw it from within a resolver, and it will be wrapped in this GraphQL error, and we can still make use of it after the request execution has finished. So, for example, or not for example, but what we are doing here is we are saying every error encapsulates a specific problem. Like, what is a problem? A problem is everything you know in your code base that could go wrong. And here it makes sense to just like step a bit back from your actual implementation and you're hacking everything in and then you're thinking about errors. But maybe think about it up front. When we were designing our first API that had to work with like hundreds of different customer data, how they defined it, before implementing, we were thinking about what could go wrong and in which forms, which sort of problems are they, how do they relate to each other. And in a very simplified form, we came up with this execution problem here, which might be things like the unknown locate that you've seen beforehand, or like an unresolvable link. If you're linking from one resource to another, but that link cannot be resolved on the database, then you might want to show like here, at this point it went wrong. And we have also query validation problems, which are like a step beforehand, like before the query is executed. So for example, on the transport layer, if the transport layer didn't receive a query, we don't need to attempt to execute it. We can say, hey, we have a missing query, and we can abort already. The same for like query formats that are invalid or variable formats that are invalid. And once you've thought about all of them, it gets pretty clear for you where in which position something in your code base could go wrong. And that confidence is gold, in my point of view, at least. Once you have that, you can like join them together. As I said, you don't need to necessarily know TypeScript for it, but it is basically a union between like different types that you have. And it says like a problem can be all of those different problem types that you have. These problems will be passed in when you're creating an error and will just be assigned to the error so that you can use them later on for formatting. Cool. So, for example, with the unknown locale, we had additional information on that, right? So how do we actually store additional problem information on it? We do that by having a distinction between the error codes, as seen here on the top. Those error codes are unique and they are static or stable, however you want to see them. So we won't change those error codes. That makes it pretty useful to use them in a so-called discriminated union, which basically means we have objects where this problem kind here is on a specific property, and based on which problem kind value it has, it knows which type it is of. So, for example, the missing query has nothing else to it, so we don't need to define any type, how it would look like. But for the unknown locale, we have the available locale codes and the actual locale code that was not found, so that we can format the error message properly. So we put the kind, problem kind, unknown locale here, and by that, the TypeScript system can figure out that whenever we are creating an error and saying the problem kind is an unknown locale, it will even be enforced by the type system that we put an unknown locale code there and an available locale codes. The same is here for the unresolvable link, just has like a bit more data because you need to say from where it points to where and what kind of type those references are. But here again, it has the kind, problem kind, unresolvable link. So once we create an unresolvable link problem, it will ask us to fill out all the other values as well. This is pretty useful and actually makes sure for us that we are always sending out the exact same shape of errors, because if we wouldn't send them out in the same way, for us, that would be a breaking change. So we can rely on a bit of type safety here as well, which makes it easier. So when we are creating an error, we are basically passing in an object because we define just interfaces. And the interface says, well, a problem always has a kind property, which is like this one of those problem kinds. Missing query has no other type built around it, like no additional information. So you can just throw it in there as a kind and you're done. When you want to do that with the unknown locale, you will be forced to put in the other two here as well. But in the end, it's still all those problems are just like objects that are in a well-known shape. So That one here is how we are formatting problems to the GraphQL specification errors, because we want them now, all those Graph API errors, we want them to look like specification compliant errors with as much useful information as we have. So we can basically just check on it. After we have went through the request execution in GraphQL, we will have like the data and the errors array, and we can just go over the errors array and say like, hey, first of all, is it like a GraphQL error that wraps anything inside? If not, we probably just want to put out some generic error handling so that we don't leak any information. But otherwise, we will probably look on the inner error that is encapsulated and can check on that whether it's a Graph API error. If it is, we can format it as specifically. If it is not, we just make like a generic error message, as I said, to just like clean out or make sure that we don't leak any information to the outside that we don't want to. So it is probably more important to look on those two things here. How do we get to the message? And how do we actually get the extensions object that we want to send out? It is basically as easy as a switch statement. And you can even put like an error throwing thing at the bottom if you wish for. But actually, you would never be able to construct a problem that has not a known problem kind if you're using TypeScript. So for the missing query, we don't have anything interpolated in there. It is just a static string, basically. But for the unknown locale, we can interpolate things from the problem into it. TypeScript knows, because we have used this case, the case unknown locale, it now knows that the union type of the problem that you have chosen is the unknown locale one. So it knows that you have an unknown locale code and even like the available locale codes that we can then use to format everything. So here, that is how it would look like for a generic case, like the missing query that has like nothing else, like no details. We can just return it, put the request ID there. Please put the request ID there, like really. And otherwise, we can just pull out the details, everything else that has been on there, and put them onto the details object. If we do so, now we will have the available locale codes on the error message, and the user who sees the error, or even a machine who reads over it, can make use of the information. Well, yeah, as I have said earlier, we weren't using the GraphQL error that was shipped with the reference implementation because it had like none of these type goodies that we were just talking about. But what that also means is we have to make sure that we actually copy over the location and the path if they are available on the outer error, so that they are now on our GraphQL error, like the specification of the GraphQL error in that JSON, it should be in. So we have to manually add them. That can be literally as easy as this. This is like copied out from our current production code, more or less. Of course, wrapped in like some other fashion. Yeah, once we have that, everything is sent out, everything's cool. As I mentioned in the beginning, we want to be differentiating between unexpected errors and expected errors, because there will always be unexpected errors. There might be, I don't know, a dependency has been updated and is now throwing some other sort of error. That might still happen and won't be wrapped in one of your problems. So those kind of things you would probably want to yell about very hard. You would put them like to Sentry, some error monitoring, whatever. But if somebody used a locale that is not known, you know that this has been handled. So why would you bother spamming all your logs with it? Like your log pipeline gets bigger, like your metrics maybe even get skewed because you think you are having a bunch of errors, even though a customer is just like trying something out against your API. Also, there might be multiple errors in a single request, and then you will have like the problem over and over again. So if you have like, I don't know, within a collection nested something asking for a specific locale, and you have it like a limit of 1,000, then you will have like 1,000 times the error that the thing is not, like the locale is not known. And like 1,000 times the same information logged. This can really heavily clutter your log pipeline. And if you're like at 4 billion requests per month, this gets at some point even expensive. So it might be cool even to look at it from this side and to optimize how you want to handle what is going on. So my better solution here is to just react differently if you know the problem. Like if there is a Graph API error, if it's not a Graph API error, then you want to capture it on Sentry. You want some developers to know about it. You want to figure out what is going on. But if not, you might want to do either nothing or maybe increase some statistics counter so that you can still look at in relations how many errors are occurring. For example, you could then judge by yourself whether it is just an increased error level because more people are picking up your API or because something was breaking in your last deployment and now suddenly you get 10 times more errors. Yeah, that is more or less the approach we are taking. And towards the end, of course, there are some limitations or pitfalls that you can run into. The one that was biting me the most is the first, that scalars, like those custom scalars, as we've seen with the date parsing, they often throw a usual type error. Like as if you would have mistyped something in your code and it says like, I don't know, type error cannot read property foo of undefined or so. Those are things you probably want to bubble up and check, have been checked by your developer. But if a customer just sends a date format that is not valid, you don't want to be notified about that in Sentry. So yeah, how do we deal with that? Same goes for like custom validations. The complexity library we have been using is creating its own error inside, which was not very much of use for us and was actually lacking some information we needed. So luckily, this implementation allowed us to create our own errors. And that is, of course, the ideal solution, right? You just replace the error creation part and just throw or return some Graph API error with a known problem inside. So, for example, like the problem is that the query is too complex. For the scalars, that is often not possible. For example, on our date scalar that we are using, like an outside module for it, we cannot change that. What you can do is you can basically pick those functions from the custom scalar for like parsing or serializing. You could wrap that to just like catch very early when that scalar is failing and return it as a Graph API error as well. That can be a bit cumbersome depending on how many custom scalars you're using. But I would recommend you to actually also think about that because we haven't initially, and it was a nightmare to see all those Sentry errors popping up in our Slack. That actually was it. I'm very happy that you bared with me here. And yeah, time for your questions. Or if you don't feel like asking in the stream here, you can reach out to me on Twitter. The handle is linked in here. And with that, I appreciate that you've been sticking with me. Thank you.
Well, Stehpan, that was really great. And I must say, I've heard here one of the best advice in GraphQL presentation ever with the request ID. So that's really great, and thank you. That's a lifesaver. So that was really good presentation and a lot of content. And we did have some questions from the audience during the presentation that I think you might have at least partially answered till the end, but we'll still give it a go so we can clarify and elaborate on them. So first one is, where do you see the line dividing events requiring errors that appear in error data, like in error objects, and unwanted behavior that would be better served by first-class GraphQL schema citizen type, like in a regular GraphQL schema?
Okay, so that is, I think, basically coming back to what Rafał was saying in his talk, right, where he was like putting some like GraphQL schema citizen types, basically putting them within the schema. I would actually like if there would be like typed errors in GraphQL, but it's like not there from the spec. And yeah, we are always trying to stick as close to the specification as possible. I have only heard about today that people are actually putting it into data, so I don't have any experience around that. For me, it kind of sounds okay if you are for mutations and things that are actually write operations. The result of that being in the schema, and like you see errors when you're trying to create something, always with the same kind of structure. that could make sense, I think. I will definitely read up into this topic afterwards because it's I only learned about it today. It's really interesting that people are tackling it like this, because we were struggling, of course, as you can see, with how errors are treated in GraphQL, and we built like our pipeline to actually make sure that they're like streamlined. And yeah, just putting more types on them by having them within the GraphQL schema actually sounds very intriguing.
Yeah, okay, great. Actually, we found that doing those typed returns with those behaviors in the mutations is exactly what is useful. And I think there's a lot of this content in the Sasha presentation that Rafał put in his slides. So I encourage everyone to look into that because it's a very good presentation too. Let's go to the next one, which is, you've mentioned a unique ID during your talk for identifying errors. Can you tell what solutions or products are you using for tracking those? Example, is it Sentry?
For the known errors, it's not Sentry, because we try to use Sentry for like things that are really hard breaking. And if we have a unique error code assigned to the problem, we obviously know about the problem. So what we are doing for some of them, we are like putting them into the logs, because we might want to log some additional information that shouldn't be disclosed to the customer, so that we can make more sense out of it, especially during like internal server errors, or when we actually hide an error and just put out the internal server error. We want to be able to look it up afterwards, and we just put them into our logging system. For the known error types, we're actually using some like, that in a simple way, just call it like statsd, like some statistics service, where we generate a key out of it, like, I don't know, GraphQL error, and then like the error code. And then we like increment those values so that we can track them over time. There's also potentially like log analytics pipelines that you just like send out data tracking events if like some of those errors happen, and then you could use, for example, systems like Redash or so to make like visualizations of the errors that are coming.
Okay, great. Thank you very much. Okay, I think we've got another one. Yes, we do. Do you support federations? How are those standards extensions, GraphQL error, would work with federations? If they are not defined, would it be a problem?
I'm not sure what you mean by if they are not defined. Like federation in itself actually would work really well, I think, because you could have in different systems having different errors, and as they are nested in under their own namespace in the extensions object, then you could just like merge them all together. You could just merge multiple namespaces in the errors together. So that would work pretty well. The extensions field is part of the GraphQL specification, as far as I know. So federation should totally work with it. I think it would be pretty useless if it wouldn't support it, because you couldn't send any information across the federated schema if you only are sticking to the message. Or it would be very hard, because you would always need to do string parsing on the message to be able to figure out what is going on. But that being said, I haven't worked with federation much.
Okay. Would you consider sharing some code between services in federation that pack those error messages and do the layout a similar way, or just follow the convention, or maybe do it some other way?
Depends on how you are doing that. Like, I mean, if they are like all in the same kind of language, you could of course think about some package that abstracts this away so that you can like use it between different services. In a polyglot system, you would probably just stick to this is like our own specification of how an error within our company looks like, and then your different languages would need to implement it to stay consistent.
Sure, that makes perfect sense. Thank you very much. Okay, so I guess that's it. Oh, no, that's not it. There's another one. Do you attach unique ID to every request or only for errors?
We do that for every request, because sometimes we might want to debug like slow requests, for example, that was still successful. In fact, when a request hits our network, we will be assigning a request ID to it that we can then like follow through our whole server infrastructure. And we will be serving that back usually on a header. But like for the errors, we are also surfacing them so that, because when you're having an error, you're more likely to need to use that request ID. So we're putting it very explicitly in there so that yeah, you can easily copy paste it out without looking on any like transport specific thing, because GraphQL is transport independent. We decided we put it inside. We don't rely on that somebody looks on the HTTP response headers to be able to figure it out.
Okay, thanks. And that's it, I guess. That's a lot of questions. Thank you, Stehpan, for everything. It was really great. And I think that's all for tonight, actually. It was really great time with you guys. And I would like to join our growing community in the meetup. We're already planning our next events on this fall, so be sure to check our social media for the news. And that's it. Thank you. Bye. See you next time.